and welcome back. In this video, we're going to take a look at abstract classes in the Java programming language. Sometimes it's useful to declare a class that we never actually intend to use to create an object. But basically, we want to use it as a superclass. Remember, a superclass is a parent class from which other classes can be inherited. So the reason why we might do this is so that we can create a base class, a superclass that describes what is common amongst all subclasses, but really doesn't make sense to create objects directly from that class. So we create this thing called an abstract superclass. So we cannot use it to instantiate objects directly. For example, we're looking at a class diagram right now that describes an example we see in the book, where employee is the base class, it's the parent class, superclass, and in addition to that, we call it an abstract class. So from employee, we're able to inherit all the goodies that come along with employee by extending that class and creating 3 new classes, salaried employee, commission employee, and hourly employee, that extend from employee class. Furthermore, the base plus commission employee is a subclass that inherits from commission employee. So here we have a few different levels. But in this particular example, we'll see that employee was actually defined as an abstract class. It didn't make a lot of sense to make it what you call a concrete class. That's the default behavior. Instead, we knew we weren't going to ever create employee objects directly, just wanted to create this abstract class to define all the common attributes that all the subclasses would use and have in common. So how do we do that? Basically, what we're going to see is we use the keyword abstract when we define the employee class. And we'll also see that abstract classes have one or more abstract methods inside of them. So abstract methods are like the default, like concrete methods, we're at the beginning where you have the name of the method and what parameters it takes, but they don't actually have an implementation. As we'll see, abstract methods don't have any code. They just describe the name of them, what they return, and their parameters. Abstract classes can contain a mixture of abstract and concrete methods. So a concrete method is just a regular method, a non-abstract method. So let's take a look at this solution. And by the way, this is in Blackboard materials in the code files that are zipped up from the chapter. Okay, now this one's a bit larger. There actually are 6 total files in the solution. And the first one I'm going to pull up is actually employee. So employee is the abstract class. So in this particular solution, we decided that we never really needed to create objects of type employee. Instead, we wanted to define what all the subclasses of employee, for example, hourly employee, salaried employee, what all of them had in common. And it kind of works like defining a template for all the subclasses. And common fields between them were always going to be, well, every employee has a first name, a last name, and a social security number. So you can see that we've defined those fields up here. Okay, and also we have a constructor that sets those values. We have a get and a set, or I'm sorry, 2 gets, first name, last name, and social security number. We also have a toString method that prints out, all the data for an individual, their first name, their last name, and their social security number. Now, all of these methods here are concrete. This one here, this last one, earnings, is used to basically return a value representing the employee's earnings. But we don't have an implementation here. You'll notice we have, the access modifier, we have the return type, we have the name of the method. Here is an empty parameter list. But afterwards, we don't have any curly braces. We just have the semicolon terminating the statement. And we have this keyword abstract, which we'll see in the instances where there is no implementation, such as we have here. The idea is that any class that inherits from an abstract class must override the abstract methods in the parent class. And that's a bit of a mouthful, but what that means is all the other classes that will inherit from this one must provide a definition, in other words, the steps to calculate the earnings in a method called earnings. So we will see that. So let's pick on hourly employee. So if you've defined an abstract class ahead of time, as we have, then we can very easily use inheritance, as we have in the last few examples, to extend that base class. So here we see that with the keyword extends. Nothing new here. We know how to do that. And we see that an hourly employee has a wage and hours that we weren't keeping track of in the generalized employee abstract class. So hourly employees have hours and a wage to keep track of that's specific to this type. So as we've seen in previous examples, we're going to see those instance variables. We're going to see that reflected here in the constructor where those values are set. And we'll see the super constructor, in other words, the constructor for the employee class being executed here in the constructor. So nothing new. We've seen these in previous videos, but these concepts rather. But that is how we can extend from an abstract class. So we just use keyword extends as we have in previous inheritance examples. So we have gets and sets. Notice this portion right here, public double earnings. So we were required to override the abstract method earnings that was specified in the employee class. Notice if we remove that method, we get an error message that indicates this class must implement the inherited abstract method earnings. So as you can see, it will actually generate an error if we do not override a abstract method that was inherited. And you'll see this, I picked on hourly employee, but you'll see that in the others as well. So if I take a look at salaried employee, instead of keeping track of hours, of course, keeps track of a weekly salary because that piece of data is specific to a salaried type of employee. So again, I'm not going to go through in detail because there's really, nothing too new here. But just want to emphasize again, for this to be a subclass, i.e. child class of class employee, we need to use the keyword extends. If we go down, again, we had to override the earnings method, and we want to return the value of the earnings, which is really our weekly salary. So we call get weekly salary to do that. So notice, even though both salaried employee and hourly employee have an earnings method, they are, of course, using different business rules to calculate those values. So I didn't go over commission employee. You can take a quick look, but same concepts. It extends employee. Base plus commission employee, let's take a peek at that one for a moment. This one doesn't extend employee, it extends commission employee. So just remember that this actually was a child class of commission employee instead of employee. So that one was a little bit different. But again, we do have our own version of earnings, which calculates the earnings of the parent class, commission employee right here. We're calling super.earnings. That's going to call earnings on the commission employee class, and it will add the base salary to that value. So those are just a really quick look at our classes. I want to encourage you to download the code and run it and see what happens. But those are the basics of the various classes and the inheritance structure that's in place. Now, things get a little interesting when we create a driver class, payroll system test here, a test class, to basically interact with these objects, create objects of type payroll system and hourly employee and so forth, and see how some of this works. Okay, so first of all, if you take a look at payroll system test, these lines from line 7 through 16 create 4 different objects. Let's pick on the first one. This particular statement is creating an object called salaried employee of type salaried employee. So that's going to create, one of the objects from this definition, right? And it's going to pass in values John Smith, his social security number, and weekly salary, and it'll pass that into that constructor. So here, here we're passing in those 4 values that will be used. And we do the same thing for hourly employee. Now notice hourly employee, the constructor in that class expects instead of the weekly salary, hourly employee, let me go to the top of the list here. That constructor expects a wage in hours at the end of the list. So here we see we're passing in a wage 16.75 for wage and hours of 40. So you'll see that the arguments that you pass, of course, correspond to the number and type of parameters that the constructors expect for each given class type. So nothing really new here. We're just having fun with our classes. So here we create our salaried employee object, hourly employee, and go on, and we do the same for commission employee and base plus commission employee. And then we have a little code that basically is saying, hey, you know what, let's just go ahead and print out what's in these objects. I'm interested to see information about them. Okay, so a couple things. We're using printf here, and we are again using a formatted string of some data. That data is coming from these values in this list. So the first argument, salaried employee, will be used for the first S here, the first string substitution, and so forth. It's going to plug those values into this formatted string. But what's interesting here is salaried employee is actually an object in and of itself. And when you reference an object in this way, it's going to call the toString method for that object. And the toString method will then be used in place of this. Then we are going to write earned, and then we're going to get the earnings from that individual object. Okay, so we're doing the same for hourly, commission, and base. Notice each time, even though we're calling earnings, such as here, we're calling it on the appropriate object, hourly employee, commission employee, and each one is going to fire off a call to the appropriate earnings method and execute the code for that particular object. Now, up to this point, in this particular file, we haven't seen anything we haven't seen yet. We already kind of knew, how to create objects of various types and invoke methods from them. Now things get interesting because I want to maintain a collection of all my employees, regardless of whether or not they're hourly or salaried. I just want to keep them in a collection. And we know that a nice way to do that in our code is by using an array. So here we're creating on line 31 a array of employees of size 4. So notice this is interesting. Notice that the type, of course, we don't have an array of ints or an array of strings. We actually have an array of objects. And the data type that we're using here is employee. So we're using the generalized abstract type, employee, as the type of data. But yet when we populate the individual elements of the array, such as we do on line 34, we are assigning the first spot in the employees array equal to salaried employee, which we know is a salaried employee data type. Following that same logic, we populate the second element in the employees array, that is index position 1, we assign hourly employee. So notice the 4 spots inside of this array are holding basically 4 different types of employees. But we can do this because all 4 of those types are of themselves inherited from employee, so they are employee types. So we are able to do this. So whereas before, up above, we printed out the data from each individual employee individually, just went out and called earnings separately for each object. Now we're going to use polymorphism, utilize polymorphism to use a loop and loop through every employee in the array and print out their information. So here we have the enhanced for loop. Recall how this works. This item to the right of the colon employees indicates the collection which we're iterating through, which is the employees array. And this item to the left defines a variable that we will use to refer to each element in our employee array as we iterate through them. So the first time through, current employee will refer to the first element in the array. Second time through, it'll be the second, so forth. So here, we're going to call print line on the current employee. Well, the first time through, that's a salaried employee. So what it's going to do is it's going to go out to the toString method defined in the salaried employee class, and it's going to execute it, because when you print an object like this, it automatically is going to execute toString. But when it comes down to which toString, it's going to use the more specific toString that applies for the current employee, which would be the toString of salaried employee. We're doing a little extra here that just basically is, checking to see if the current employee is of type base plus commission employee, and if so, I believe we're increasing their salary. Just kind of playing with the numbers here a bit. But the interesting part is you can use instance of followed by a class name, and this expression right here, if current employee instance of base plus commission employee, will return either true or false. And if it returns true, that means that the data, it is of type base plus commission employee. So we go through all of that, And then, so we're going to loop through. We're going to print out all the data for each employee. If it's a base plus commission employee, we do a little extra. And then finally, we have one more for loop. This is the traditional for loop. Loops through and prints out a statement. Employee, blank is a, and then it's going to say the name of the class. Well, it gets those values. The first is just the index value, employee 0, and then is a, and then this expression here is important. If you're after what is the class name of this object, you can always invoke the getClass method on a particular object and then .getName. So getClass returns the class, and then from that you can get the name. So this highlighted portion right here is going to return for us the class name. So I'm going to go ahead and run this, take a look at the output. So we see employees processed individually, and we see this portion that I'm going to highlight here illustrates, when we had gone through and we'd invoked toString individually on each of the 4 object types. This that I have highlighted is pretty much identical to what we have down here, except for I think at one point we updated the base salary with a 10% increase for Bob Lewis. But the point is we were able to loop through and utilize polymorphism to refer to the individual object when we needed to. When we called toString on the general employee, it found the specific object type, such as hourly employee or commission employee. It found that appropriate toString method and executed it. So if you look carefully, the salaried employee has, a weekly salary. Well, that makes sense. So the toString, it's executing the appropriate toString for the individual object. So here when we get to hourly employee Karen Price, it's printing out the hourly wage. So this portion I have highlighted right there is coming from this for loop that processes every element in the array employees, and we print out the current employee we're processing, which invokes toString, but again, it knows that this general employee is an underlying salaried employee or hourly or commission or so forth, and it executes that appropriate type of class. It executes that particular toString. And then finally, that last bit of the code went through and printed out employee 0 is a, and then remember we used the getClass, getName methods in order to return the class name. So that's how we could get at the individual class name of each of the objects.